When we learn something, when we try to achieve something, it takes efforts and commitment. However, when we know what we are going to achieve in the end, this gives us motivation and energy, which helps us in continuing our journey. This is called begin with the end in mind. In this video, we will do the same for our object-oriented learning. First, we will see how our code looks today, and then you will get a glimpse of the code you will be creating by the end. You are watching Code Like an Architect series with Adil Atta on Archi Wisdom. Suppose you are working on a project, a task management system. In this project, you are assigned a story. As a user, I want to create a new ticket. Description: user navigates to create ticket form. User fills the form with necessary information. System receives the request. System creates the ticket with the given information. Then, system checks the user's subscription. If the subscription is premium, system assigns the ticket based on priority assignment algorithm. If the subscription is a standard, system assigns the ticket based on a standard assignment algorithm. And if the subscription is basic or free, system assigns the ticket based on normal assignment algorithm. There are 3 types of assignment algorithms in the system. Once the ticket is created and assigned, then the system sends a notification to the assignee. System logs an activity for this event, and system notifies the integrated systems through webhooks. We already have a base project set up. We have a presentation layer, a business layer, and a data access layer. In data access layer, we have entities and the base functionality to apply CRUD operations. As per our requirements, we have to send a notification, log an activity, and notify integrated systems through webhooks. We have base functionality available to do these things as well. We have a notification manager to send notifications, an activity manager to log an activity, and a webhooks manager to notify the integrated systems. This is our controller class, and this is the method which will be called when our API is hit. Developers often start putting their business logic directly into this method, but that's not a good idea. If you ever need to reuse the same functionality with other channels like GraphQL or messaging or command line interface, it will be hard to make that work. Fortunately, in our project, we already have a business layer available. Therefore, all we have to do here is call our business layer. This is our business layer. Now let's see how developers typically approach their programming problems. This is the story that we have to implement. First, let's do some basic validations. Then, we have to create a ticket. To do so, we need iCRUD service. Let's inject that and also inject the other dependencies that we are going to need later. Once the ticket is created, we have to check our subscription. If the subscription is premium, we have to assign the ticket based on priority assignment algorithm. If it's standard, we have to use a standard assignment algorithm. And if basic or free, we have to use normal assignment algorithm. Once the ticket is created and assigned, then we have to send a notification, log an activity, and notify integrated systems through webhooks. That's how our implementation looks like. Analysis. First, let's look at some of the positive points. As you can see, we already have a data access layer, a business layer, and a presentation layer, which means our data access, business, and presentation logic don't mix up, which is a good thing. We also have dedicated classes for some base functionality like sending notification, logging an activity, and notifying through webhooks. This gives us some high-level organization. In our business layer, we have a ticket service class, which has dedicated methods for each story. For this story, we created the create ticket async method and implemented the functionality within it. If we continue our implementation following the same organization, we will have more methods like this. As you can see, this helps bring some organization. What's the problem? The problem lies in the approach. Developers don't break down their problems into further objects, when working on a story. In this project, we already have a high-level organization. We have some layers and some base functionality. Developers, when it comes to implementing a story, they do follow the high-level design that's already given, but they don't design any further components on the story level on their own. Remember the analogy of a well-organized home? Suppose I have a bookshelf for books, a wardrobe for clothes, and some cabinets in the kitchen for spices and other kitchen accessories. This is my high level organization. Now, if I need a book, I go straight to the bookshelf. I don't need to check the wardrobe or the cabinets. I know I keep my books on the shelf. This high level organization saves me time and efforts by preventing me from checking the whole house. But imagine I have hundreds or even thousands of books with no organization or categorization. In that case, I would have to go through all the books before finding the one I'm looking for. On the other hand, if the books were organized into categories like history, literature, religion, self development, novels, technical, it would be much easier for me to find a book. For example, if I needed the 7 habits of highly effective people, I would go straight to the self development section instead of searching the entire bookshelf. Similarly, if I needed software architecture, the hard parts, I would head straight to the technical section. Now, look at the code. We have a presentation layer, a business layer, and a data access layer. In our business layer, we have a ticket service class, which has separate methods for each story. This is our high-level organization. Now, a question. Suppose a bug is reported in ticket creation logic, and we have to troubleshoot that bug. How should I approach it? Where should I add a breakpoint to start troubleshooting? Here? Why? There is a lot more code in this project, and there are many other methods in this class. How do we know that we have to add our breakpoint on this method? The answer is we have a bug in the ticket creation logic. And based on our high-level organization, we know that this method deals with the ticket creation. We know this because of the object design. We know this because of our high-level organization. This organization helps. But unfortunately, we don't have any further organization from this point onwards. From this point onwards, I will have to search through the entire story, no matter how big it is, just to find a small bug I'm trying to fix. Developers don't break down their problems into further objects when working on a story. Which means from this point onwards, we are not truly doing object-oriented programming anymore. We have abandoned doing object-oriented programming. As a result, we won't experience the benefits of object-oriented programming that we read about theoretically. From this point onwards, our code is not going to be modular, readable, reusable, maintainable, flexible, generic, abstract, and so on. This is the fundamental problem in the approach that many developers take. And that's the reason they don't get practical benefits of OOP. Now let's code like an architect. Architects think in terms of components. Also in OOP, we solve our programming problems by designing components that contain code, which we call object or class. And then we interconnect those components in OOP using inheritance or composition. Now let's solve the same problem using architect's approach, or you can simply call it object-oriented approach. Let's implement the same story again, but this time without abandoning our object-oriented thinking. Right now we have a dedicated method for each story. Let's improve this separation of concerns. Rather than isolating each story in methods, let's isolate them in separate classes. I'm going to create a new folder, commands. Inside that folder, I will create a dedicated class for each story. For this story, we will create ticket command. Let's move the existing code inside this class. After moving the code, we will make some modifications. Let's keep the basic validation and ticket creation as it is for now. After ticket creation, we need to assign the ticket. And for that, we have to apply assignment algorithms based on users' subscription. Rather than keeping all of that code inside this method, let's think in terms of objects. Here, we will apply the combination of factory and strategy pattern, which is a known combination in such scenarios. Now we have encapsulated our assignment algorithms into separate classes. We also have a factory class, which has a method create. We pass this method user's subscription. Based on subscription, it creates relevant assignment strategy object and returns that. The assignment strategy object returned by the create method is assigned to assignment strategy variable. And then when we call assignment strategy.assign method, the relevant assignment algorithm is applied. Now, once the ticket is created and assigned, then we have to send a notification, log an activity, and notify integrated systems. Now, if you think carefully, the main business logic of our story is basically ticket creation and assignment. The notification, activity log, and webhooks part are kind of post-event actions. If you think about it, these post-event actions are going to be associated with almost any story we do. Think about when we do delete ticket. When we delete a ticket, we may need to send a notification, log an activity, and notify through webhooks in that case as well. These are actually some post-event actions which are not specific to only this story. It's not a good idea to keep these post-event actions inside this method. We should keep them separate in a way that we don't need to modify this method again and again whenever a change is required in them. For that, we need some sort of inversion of control. We need to think about designing these post-event actions. Let's stop here and do some base work. We have to come up with some design and then continue. Now, after doing a little work, we have added support of events in our system. Now we can create new events. We can publish those events, and we can subscribe to events using handlers. Let's first implement our post-event actions using this new support of events and then discuss.
Now let's see how we have implemented our post-event actions.
First, we have created a new event in our events folder, which is ticket created event. Then we injected iEventPublisher in our createTicket command class. Then in our method, when our main business logic is done, we have published this event using eventPublisher.publishAsync method. On the other hand, we have created few handlers under event handlers folder. We have created ticket created activity log handler. This class is responsible for logging an activity against ticket created event. Next, we have ticket created notification handler, which is responsible for sending notification against ticket created event. And then we have ticket created webhooks handler. Next, we have registered our ticket created event and we have subscribed our handlers. Once we have subscribed our handlers, our base work will take care of calling all those handlers whenever this event is published. That's how our implementation looks like. Analysis. First, just place both pieces of code side by side and observe the difference. Now see, this is our high-level organization. In addition, now we have further code organization available at the story level as well. Notice the difference in approach. Now we are not abandoning using object-oriented programming while working on a story. Now we can see inside a story as well. Now we can see further components inside our ticket creation logic. This is the class that handles our main story. Inside it, this is the class that manages the priority assignment algorithm. This one manages the standard algorithm and this one manages the normal assignment algorithm. Furthermore, this handler sends notification. This one handles activity log and this one notifies the integrated systems. Now, if a bug is reported in the priority assignment algorithm, I know I have to look into this class. How do I know this? The design helps me. Now we have further code organization available at the story level as well. If a change is required in ticket created notification, I will jump to this class. Similarly, if there is an issue in a standard assignment algorithm, I will open this class. We can easily apply changes here without needing to understand the whole ticket creation logic and without risking breaking any other implementation. If we continue implementing our stories following the same approach, then after some time our code will look like this. Inside our commands folder, we will have many other classes, one for each story. Similarly, inside our events folder, we will have many events. Inside our event handlers folder, we will have many other event handlers. Now, if I want to know the current functionality set of the system, or suppose if a new developer is assigned to this project and he wants to develop an understanding of the existing functionality, he'll be able to get an idea of the current feature set very easily just by looking at the commands folder. Suppose we have assigned few bugs and tickets to a new developer who is very new to this code. Suppose a bug has been reported in notification after deleting a ticket. After developing a little bit of understanding, the new developer will very quickly realize that there must be a handler to send notification after ticket deletion. Hopefully, he will find this class and fix the bug. See how easy it is to find something in this code, even for a new developer. They don't even need to run the application or add a breakpoint and then go through the code step by step. They are jumping directly to the area of the code where a fix or change is required. This is very different from a developer's typical coding experience. By organizing our code into further objects, we have completely transformed our coding experience. Let's continue our analysis. Suppose we haven't maintained a good documentation of this project, and someone requests a developer to document the list of notifications that our system sends. If you assigned the same job in the previous code, you will find it very difficult to find a reliable list of notifications. But in this code, All you need to do is this. Here's your list. It only took seconds to find a reliable list. You can add new handlers, as many as you want. Remove existing ones and replace them. All of that without even needing to change a single line of code in any other class. Imagine you are sitting in a discussion and someone asks, "Do we get notifications when someone comments on a ticket?" You will turn your face to your system and in 5 seconds you will say, "No." What you have seen is just a glimpse of what's ahead. We have only scratched the surface. We haven't yet unlocked the true power of all that's about to come. Did you find this interesting and motivating? Do you want to code like an architect? If yes, please let me know. And keep watching.